A 25-pound animal killed and fed on a 52-pound apex predator in the Florida swamp. And for 20 years, biologists had assumed that particular fight only ever went one direction. Nobody believed a native predator could actually win this matchup. Not at that size difference, not against an invasive species that has spent 3 decades quietly eating its way through the Everglades food web with almost no resistance. Then a trail camera caught something on tape that should not have been possible, and it forced researchers who had spent their careers documenting decline to sit with a very different kind of footage for the first time. By the end of this, you are going to see exactly what that camera captured and why it complicates a story everyone thought was already over. The Everglades does not look like a battlefield. It looks, from a boat gliding through it at dawn, like the most peaceful place left in Florida, a slow-moving river of grass stretching for 1.5 million acres, dense with sawgrass prairies, cypress domes, and mangrove tunnels that filter drinking water for millions of people downstream. Herons stand motionless in the shallows. Alligators drift beneath duckweed with only their eyes above the surface. It is easy to stand at the edge of this landscape and feel like you're looking at something ancient and untouched, a wilderness running on the same rhythms it has followed for thousands of years. For a very long time, that feeling was mostly accurate. The system had been running, largely uninterrupted, since long before anyone thought to draw a map of it. Scientists who study this specific wetland do not talk about it the way tourists do, as scenery to be admired from a boardwalk. They describe it as an engine, a functioning machine of interlocking parts, absorbing storm surge, recharging the aquifer that supplies drinking water to millions of South Floridians, and hosting a food web layered so deeply that removing even one piece from it can send consequences rippling outward in directions nobody predicted in advance. Its ecological value has been estimated in the tens of billions of dollars annually, not from tourism dollars, but from the practical, unglamorous services the wetland performs, simply by continuing to exist and function the way it evolved to function over thousands of years. That is the baseline worth holding on to before anything else in this story, because everything that follows is a disruption to a system that was, by every measure available, working. That began changing in the 1990s, and the reasons are documented, mundane and human, rather than dramatic. Burmese pythons, native to Southeast Asia, entered Florida primarily through the exotic pet trade, a booming market at the time for large, exotic reptiles that looked impressive in a tank as hatchlings and became unmanageable within a few years as they grew into 10, 15, occasionally 20-foot adults. Overwhelmed owners released them. Some escaped or were accidentally freed when a reptile breeding facility near Miami was damaged during Hurricane Andrew in August of 1992, a Category 5 storm that tore through the region and scattered an unknown number of captive snakes into the surrounding wetlands. The Everglades, warm, humid, and full of prey with zero evolutionary experience of a heat-sensing ambush predator this size, turned out to be close to perfect habitat. Nobody designed this outcome. It emerged from a chain of ordinary decisions, pet purchases, escaped enclosures, a hurricane, compounding quietly for years before anyone realized how far it had already gone. What happened next is the part most people already know, at least in outline, because it has been covered extensively in mainstream wildlife journalism for over a decade now. Python numbers exploded, aided by the near-total absence of natural predators and a reproductive capacity that let a single female lay up to 100 eggs in a clutch. Researchers tracking mammal populations in the hardest-hit zones of the Everglades documented catastrophic, well-published declines. Raccoon populations down by well over 90% in surveyed areas, opossums and bobcats showing similarly severe drops, and entire stretches of habitat that once teemed with visible wildlife going eerily, measurably quiet. This is not exaggeration. It is published, peer-reviewed ecological data, and it is the reason Burmese pythons are considered one of the most damaging invasive species currently established anywhere in the continental United States. And this is also exactly why what happened in December of 2022, and in the years of parasite research running alongside it, deserves to be understood as genuinely surprising rather than simply more of the same decline. Something in this system, after 20 years of one-directional collapse, started pushing back. Something else, moving through the same swamp at a scale too small to see with the naked eye, started quietly reshaping the fight from underneath. Neither of those threads has an ending yet, and that is exactly what makes the real footage worth looking at closely. Here's why, for most of the past 2 decades, the mainstream understanding of this crisis settled into a story of straightforward, one-way ecological collapse. And it is worth taking that story seriously before complicating it, because the researchers who documented it were not being alarmist. They were reporting exactly what their data showed. A landmark study published in the Proceedings of the National Academy of Sciences laid out mammal population crashes across the hardest-hit survey zones in numbers stark enough to stop the wildlife biology community cold, Raccoons down over 90%, opossums down nearly as steeply, bobcats and other mid-sized mammals showing similarly severe declines in areas of heaviest python density. Field researchers who had spent decades working these same stretches of swamp described driving for miles through habitat that used to be visibly, audibly alive and finding almost nothing, no movement in the underbrush, no eyes catching headlights at night, just an unsettling stillness where a functioning food web used to be. That kind of finding, once published, does not stay confined to academic journals. It reshapes how an entire field talks about a place. Wildlife managers, conservation nonprofits, and journalists covering the Everglades for the following decade largely organized their reporting around a single, coherent narrative arc. Introduction, explosion, collapse, with the only open question being how much of the original ecosystem could realistically be salvaged rather than whether collapse itself was underway. That framing was not lazy or sensationalized. It reflected the best available data at the time, gathered by credentialed researchers using standard survey methodology, and it accurately captured what was actually happening to the mammal populations being tracked. Anyone entering this field of study in the 2010s inherited a genuinely grim, well-supported baseline expectation, and there was no dishonesty in that expectation. There was simply not yet enough contradicting data to suggest the story might eventually need a second chapter. The response to that crisis made sense on paper, too. Florida's wildlife agencies, facing an invasive predator with no natural population checks, turned to public hunting programs, most visibly the Florida Python Challenge, an annual event inviting members of the public to search out and humanely remove pythons for cash prizes. The optics of the program drew plenty of attention, but the underlying math was always going to be difficult. Removing a few hundred snakes from an estimated population in the tens of thousands to low hundreds of thousands, spread across 1.5 million acres of some of the densest, most difficult terrain in the country, was never going to meaningfully dent the population through public hunting alone. Researchers understood this going in. The program's real value was public engagement and incremental removal, not population-level control, and treating it as a failure misses the more sober assessment the scientific community had already reached. No existing tool available in the mid-2010s was going to solve this problem outright, and everyone working the issue professionally knew it. That is why, starting in 2013, researchers at the Conservancy of Southwest Florida shifted toward a more surgical approach, one built specifically around the python's own biology rather than brute force removal. The method, sometimes called scout snake tracking, involves radio collaring adult male pythons and following their movements during breeding season when instinct drives them directly to reproductively active females. Locate the male, and you often locate the female he is trying to reach, along with her clutch of up to 100 eggs before any of them ever hatch. It is patient, unglamorous, physically demanding field work, wading and boating through mangrove tunnels and sawgrass for hours at a stretch, tracking a signal that might lead nowhere or might lead to a 15-foot female buried in a burrow. Over more than a decade, this method has become one of the most effective tools available for actually removing reproductively significant pythons from the population. And it is the exact program that put biologists in the field tracking one particular snake on an otherwise unremarkable cold morning in December of 2022. To understand why this specific method matters so much to the story that follows, it helps to understand what it actually produces that broader survey techniques cannot. A population estimate, however carefully modeled, tells you roughly how many pythons might exist across a given range. It does not tell you what any individual snake is doing, where it travels, what kills it, or what condition its body is in when researchers eventually recover it. Scout snake tracking, by contrast, generates exactly that kind of individual-level detail because researchers are following specific, named radio-collared animals over months or years, building a kind of biography for each one. That granularity is precisely what allowed Bartoszek's team to notice, immediately and with confidence, that something about Loki's death did not match the expected pattern, rather than simply logging one more python carcass among thousands and moving on. Here's where it starts to get stranger than the standard decline narrative allows for, and the first crack shows up in the field notes of that specific December morning. The snake being tracked that day was a 13-foot, 52-pound male python researchers had nicknamed Loki, a scout snake whose radio collar the Conservancy team had been following for weeks, expecting his signal to lead them, as it usually did during breeding season, to a large egg-bearing female. Instead, when the team reached his coordinates, they found his body already dead, his head and neck gnawed away, the remains partially buried under a scattering of pine needles nearby. That burial pattern was the first thing that caught their attention, because caching a kill under debris like that is specific, recognizable behavior associated with two possible predators in this ecosystem. A Florida panther, of which barely 200 remain in the wild statewide, or a bobcat, a far more common resident of the same terrain. Now look closer, because the math here should not have worked in the bobcat's favor at all. A typical Florida bobcat weighs somewhere in the range of 15 to 30 pounds. Loki weighed 52. That is not a marginal size gap. That is closer to double the weight, closer to what you would expect to see written up as evidence the smaller animal simply could not compete, the kind of mismatch biologists would normally expect to end with the python as the predator rather than the prey. Bobcats and panthers are both known to revisit their kill sites to continue feeding, so the conservancy team, working on the reasonable hunch that whichever animal had killed Loki would likely come back, set up a trail camera at the site and waited. Here's where it gets stranger still. The camera caught it. Not a panther, whose rarity would have made this an almost statistically improbable event on its own, but a 25-pound bobcat, walking directly back into frame to resume feeding on the same 52-pound python it had apparently already killed. Ian Bartosik, the wildlife biologist who found Loki's remains and has spent more than 12 years tracking pythons in this exact region, described the moment plainly. A 25-pound cat had killed and cached a 52-pound python, and he called it a genuine win for the home team. The first time on record that a Florida bobcat had been documented killing one of these snakes. Now consider what makes this even stranger once you look at the broader context researchers already had on file. This was not the first time bobcats and pythons had crossed paths in a lethal encounter, but every previous documented interaction between the two species had run in the opposite direction. During routine necropsies on captured pythons over the years, researchers examining stomach contents had specifically found bobcat claws inside python remains, direct physical evidence that pythons had been successfully killing and eating bobcats for as long as anyone had been cutting these snakes open to see what they contained. The established pattern, backed by physical forensic evidence sitting in specimen jars, ran overwhelmingly one direction. Loki's death was the first confirmed instance on record of that pattern reversing. So here is the question that hangs unanswered over everything that follows. Was Loki's death a genuine, meaningful signal that native Everglades predators are beginning to adapt, learning or evolving new tactics against a predator that has had the run of this ecosystem for 2 decades? Or was it simply a single, statistically unlikely event, one unlucky snake caught at exactly the wrong, vulnerable moment by exactly the wrong opportunistic cat? A story that feels bigger than it actually is because it is the only one of its kind currently on record. Researchers themselves have been careful not to overclaim in either direction, and that caution is exactly where the next phase of the investigation had to begin. A single data point, however striking, is not the same thing as a trend, and the field's next task was not to celebrate, but to go looking, carefully and skeptically, for whatever else might already be sitting quietly in the record, waiting to be recognized as part of a larger pattern rather than dismissed as one strange afternoon in the swamp. The investigation into what Loki's death actually represents does not happen in a single dramatic afternoon. It happens the way most real wildlife science happens, through years of accumulated observation, cross-referenced necropsy data, and a separate, quieter research thread running in parallel that most people covering this story never even connect to it. Start with what the Conservancy of Southwest Florida's broader body of work already tells you about how seriously to weigh a single data point like Loki's death. Bartosik's team has spent more than a decade refining scout snake tracking, specifically because it lets them gather exactly this kind of granular, individual-level data on pythons that broader population surveys simply cannot capture. Over that time, the program has documented staggering totals, cumulative removals well into the tens of thousands of pounds of python biomass, over 1,000 individual snakes taken out of an area covering less than 100 square miles. That scale of sustained, individual-level tracking is precisely what allowed researchers to notice something as specific and rare as a single bobcat predation event in the first place, and to recognize immediately how unusual it was against the broader forensic record of bobcat claws consistently turning up inside python stomachs instead. In the months following Loki's death, Bartosik's team began deliberately widening their attention, reviewing trail camera data and necropsy records with a specific new question in mind. Had anything like this happened before, anywhere else in their monitoring area, that simply had not been flagged as significant at the time? This kind of retroactive review is unglamorous, invisible work, the opposite of a dramatic laboratory reveal, but it is exactly how real field science actually tests whether a single striking observation represents a genuine pattern or an outlier. It requires going back through years of accumulated data, checking specimen records, comparing camera trap footage across multiple sites, looking for anything that might have been present all along but overlooked because nobody had yet seen the one event dramatic enough to make the pattern visible. Running alongside that predator-focused investigation, and largely disconnected from it in most public coverage, a separate team of researchers had already spent a decade tracking a very different kind of threat moving through the exact same ecosystem, one invisible to any trail camera. In 2012, invasion ecologist Melissa Miller, affiliated with the University of Florida, identified a native Florida snake infected with an unfamiliar parasite. a thin, worm-like organism later identified as Rileyetiella orientalis, a pentastome native to Southeast Asia and Africa that lives in the respiratory tract of its host. Miller's subsequent research traced the parasite's introduction to the exact same source responsible for the broader crisis, the Burmese python, which had carried the parasite with it from its native range and, through the ordinary mechanics of a shared ecosystem, allowed it to spread into native species that had no prior evolutionary exposure to it. The transmission pathway researchers eventually mapped out is genuinely unsettling in its ordinariness. Infected pythons pass parasite eggs in their waste. Cockroaches, scavenging that waste, pick up the eggs. Frogs and lizards eat the cockroaches. Native snakes eat the frogs and lizards. And once inside a new snake host, the larvae migrate specifically to the lungs, where they mature, feed, and multiply, gradually compromising the animal's ability to breathe until, in the more severe documented cases, the infection proves fatal. What makes this pathway particularly difficult to contain, compared to something like direct predation, is precisely its ordinariness. Cockroaches, frogs, and small lizards are among the most common, widely distributed animals in the entire ecosystem, meaning the parasite does not need pythons and native snakes to interact directly at all in order to keep spreading. It simply needs the everyday food chain of the swamp to keep functioning normally, which it always will, and every ordinary meal a native snake eats becomes a potential point of exposure. A peer-reviewed 2020 study with Miller and researcher Cristina Romagosa among the authors formally documented the parasite's spillover into at least 13 native snake species, in areas where pythons and native snakes overlapped. Follow-up tracking by researchers including University of Central Florida doctoral student Jenna Palmisano, working through a coordinated monitoring effort called the Snake Lungworm Alliance and Monitoring Program, has since documented the parasite spreading well beyond its original range, now confirmed in at least 18 native snake species across roughly 25 Florida counties, reaching as far north as parts of the state that have never had an established wild python population at all. Picture what that means when you place both investigations side by side. The bobcat's trail camera and the parasite researchers' specimen logs running on entirely separate timelines, but converging on the same underlying question. One team is documenting a rare, hopeful sign that native predators may occasionally be capable of striking back against the invader directly. Another team, working with microscopes and necropsy tables rather than trail cameras, is documenting a second, quieter front in the same war, one where the invader's influence is spreading not through direct predation at all, but through something biological and self-sustaining that native snakes cannot outadapt or outrun. Neither team, as of the most recent published research, has definitively connected these two threads into a single unified finding. That gap, the fact that the predator pushback story and the parasite spread story are still being told largely as separate narratives by separate research groups, is itself part of what makes the full picture here so difficult to resolve into a single clean conclusion. The reveal, when you actually sit with everything the real data shows rather than the simplified version that circulates online, is not a single dramatic scene inside one laboratory. It is the specific, quiet moment field researchers had to confront once they laid the bobcat data next to the parasite data and realized neither story, on its own, tells you whether the Everglades is actually recovering or simply changing shape while continuing to lose ground. Picture the actual working environment this conclusion emerged from, because it looks nothing like a control room with monitors and dramatic lighting. It looks like a field office cluttered with necropsy logs, trail camera memory cards waiting to be reviewed, GPS tracking software open on a laptop screen, and researchers who have spent over a decade in wet boots comparing notes across projects that technically fall under different funding streams and different institutional homes. Bartoszek's team, reviewing Loki's case alongside years of prior necropsy data showing bobcat claws consistently found inside python stomachs, has to sit with an honest, unglamorous statistical reality. One confirmed reversal, however genuinely significant as a first, does not overturn a pattern otherwise documented running overwhelmingly in the opposite direction for over a decade. Meanwhile, Miller and Romagosa's parasite research, tracking 18 infected native species across 25 counties and expanding, cannot yet say with certainty what the long-term population level consequence of that spread will be, because the field currently lacks a comprehensive understanding of the disease's sublethal effects and how they translate into long-term survivorship for infected populations. Here is the plain language version of what that actually means, translated out of the careful hedge-everything language real researchers use. A python was killed by a bobcat for the first time on record, and that is real and it matters, and it is the kind of detail that deserves to be celebrated as a genuine, hard-won data point rather than dismissed. But it is one confirmed event, not yet a documented trend, and it is running alongside a second, less visible crisis in which a parasite carried by the very same invasive species is now confirmed in 18 native snake species, and spreading into counties that have never seen a wild python at all. The swamp is not simply collapsing anymore, the way the story was told for most of the last 2 decades. It is also not simply recovering. It is doing something more complicated and considerably harder to summarize in a single headline, fighting back in one measurable, hopeful way, while simultaneously absorbing a second, slower-moving threat that nobody with a trail camera can actually photograph. Sit with that for a second, because it is genuinely stranger and more honest than either the purely triumphant version or the purely apocalyptic version of the story that tend to circulate separately online. The same ecosystem producing footage of a native bobcat successfully taking down an invasive apex predator twice its own size is also, in the same years, in the same wetlands, quietly absorbing a respiratory parasite now documented in native species as far away as counties that have never had a python problem at all. Neither fact cancels the other out. Both are real. Both are currently being tracked by credentialed researchers using real, cited, peer-reviewed methodology, and neither one, on its own, tells you how this actually ends. Think about what that means for anyone trying to responsibly summarize this ecosystem's condition in a single sentence, the way headlines and video titles are almost always forced to do. Reduce it to native predators are fighting back, and you have told a true, a verified, genuinely inspiring story while quietly leaving out a parasite crisis expanding into new counties every year. Reduce it to the invasion is winning, and you erase a real, hard-documented, first-of-its-kind predation event that field biologists themselves are treating as a meaningful, if still singular, milestone. The honest version requires holding both threads at once, refusing the tidy resolution either framing offers on its own, which is exactly the kind of complexity that rarely survives translation into a 6-minute video, and exactly the kind of complexity this one is going to hold on to anyway. What it means for how you should understand every piece of Everglades wildlife content you encounter going forward is worth being direct about. It means the swamp's story right now cannot be honestly compressed into either nature is healing or the invasion has won, because both framings are currently true in different overlapping ways, at the same time, in the same place. It means a single viral trail camera clip, however genuinely remarkable, represents one data point inside a much larger, messier, still unfolding data set. And treating one bobcat kill as proof of a broad ecological turnaround would be exactly the kind of overreach the researchers who actually found it have been careful to avoid in their own public statements. And it means the parasite thread, the quieter of the two stories, deserves at least as much attention as the dramatic predator footage, because its geographic spread into counties with no established python population at all suggests it may end up shaping the Everglades' native snake populations more profoundly over a longer timescale than any single predator versus python encounter ever could. That raises questions the field genuinely has not answered yet, and it would undercut everything already said here to pretend otherwise. Was Loki's death evidence of a learned, replicable behavior that other bobcats in the region are beginning to adopt? Or was it an isolated event involving one unusually bold or opportunistic individual animal that may never be repeated at meaningful scale? Researchers have not yet documented a second confirmed case as of the most recent published reporting, which means the honest answer, right now, is that nobody knows. How far will the lungworm parasite ultimately spread? And what will its long-term effect actually be on native snake populations, already stressed by habitat loss and the broader python invasion? Given that researchers themselves have stated plainly that a comprehensive understanding of the parasite's sublethal effects on long-term survivorship simply does not exist yet. And practically, given that these two research threads, predator adaptation and parasite spread, are being tracked by different teams working largely in parallel rather than in direct collaboration, is there a meaningful ecological connection between them that has not yet been formally studied? Some way the parasite's spread might be affecting the very predator populations that would otherwise be pushing back against pythons directly. To be fully honest about where the science currently stands, because pretending otherwise would undercut everything said so far. No formal study has been published connecting the predator adaptation thread to the parasite spread thread as a single unified phenomenon. They remain in the current published literature two separate stories, tracked by two separate groups of researchers, running through the same ecosystem at the same time, without a confirmed causal link between them. That gap is not a failure of the science. It is simply where the science currently sits, and any version of this story that presents the two threads as already formally connected would be overstating what has actually been established. There's a bigger pattern worth naming before we close this out, one that extends well past this single swamp. We tend to want ecological stories to resolve cleanly, victory or defeat, recovery or collapse, because clean resolutions are satisfying and shareable in a way that ongoing uncertainty never quite manages to be. The real, current, honestly reported state of the Everglades right now refuses that kind of resolution. A bobcat really did kill a python for the first time on record, and that is worth genuine celebration. A parasite really is spreading through native snake populations at a pace and geographic reach that outstrips almost anyone's early projections, and that is worth genuine concern. Both of those facts are true at once, tracked by real scientists, published in real journals, still unfolding as you watch this. That refusal to resolve cleanly is not a flaw in the reporting. It is the most accurate available description of an ecosystem this large, this complex, and this actively contested between an invasive species, the researchers fighting it, and the native wildlife caught in between. Every headline you will ever read about the Everglades from this point forward is going to have to choose which half of this story to emphasize, and knowing that both halves are simultaneously true puts you in a better position than most people scrolling past those headlines will ever be. Run it back one more time. 20 years of documented catastrophic mammal decline across the hardest hit zones of the Everglades, a patient decade-long tracking program built specifically to fight back against a population too large for public hunting alone to control. One December morning in 2022, when a 52-pound python named Loki turned up dead, and a trail camera that caught for the first time on record the specific animal responsible, a 25-pound bobcat, half his size, feeding on the kill, and running quietly alongside that hopeful footage. A parasite first identified in 2012, now confirmed in 18 native species across 25 counties and still spreading, its long-term consequences still genuinely unknown. So here is what I want to know from you. Given that the researchers who actually study this swamp still cannot tell you whether it is winning or losing, which of these two threads do you think will end up mattering more in 20 years? The predators learning to fight back, or the parasite nobody can see coming? Tell me in the comments. I read every single one. And if this pulled you in, wait until you see what happened when researchers went looking for the very first documented case of a Florida alligator taking down a python on its own. That story is next. Go watch it.